Okay, so we all know we're in the middle of this huge AI revolution, right? But it's got this massive hidden problem. Today, we're going to dive into a brand new technology called LightGen that, well, it might just be the solution we've been waiting for. I mean, it's just an incredible time to be alive, isn't it? We have tools like ChatGPT and Dolly, generative AI that can write stories, compose music, create these stunning images and videos from just a handful of words. It's almost like having a direct paintbrush for our imagination, a tool that can bring literally any idea, no matter how wild, to life. But all of this magic, it has a dark side, a hidden cost that's growing and growing fast. And honestly, it could stop all this amazing progress right in its tracks. So, what is this issue? Well, it's AI's absolutely insatiable hunger for energy. As these models get more powerful, more capable, more creative, their demand for electricity and raw computing power is just skyrocketing. And this, right here, is the big paradox of modern AI. On one hand, you have this unbelievable creative power, but on the other, you have data centers that are burning the same amount of energy as entire cities, generating incredible amounts of heat and a massive growing carbon footprint. Our progress is coming at a really steep and maybe unsustainable price. Just think about this for a second. The energy it takes to train just one of these big AI models can have the same carbon footprint as several cars over their entire lifetimes. That is the hidden environmental cost behind every single AI-generated image or paragraph. So, that sounds pretty bleak, right? But what if? What if there was a completely different way to do this? A really radical alternative to our current computers that could solve this energy crisis and maybe unlock a whole new era of AI. And this is where the promise of light comes into the picture. The solution is this really cool idea called optical computing. And here's the gist. Instead of forcing electrons through wires, which, by the way, is how all of our modern electronics work, imagine processing information using photons, the actual particles of light itself. And this slide, wow, it just perfectly illustrates the difference. Electronic computing using electrons is kind of like cars in heavy traffic. Yeah, they're fast, but they get stuck, they generate a ton of heat, and they can crash into each other. Optical computing using photons is like beams of light. They travel at, well, the speed of light, they produce almost zero heat, and they can pass right through each other with no interference. It is, on a fundamental level, just so much more efficient. Okay, so you might be thinking, if this is so great, why are we already using it? Well, the idea has actually been around for decades, but optical computing has always struggled with the kind of complex, multi-layered thinking that generative AI needs. It was great for simple stuff, but for creating art, not so much. Until now. And that brings us to the breakthrough, the reason we're talking about this today. In a recent paper published in the journal Science, researchers from Shanghai Jiao Tong and Tsinghua universities announced the LightGen chip. It's the world's first all-optical chip designed specifically for generative AI. So how on earth does this thing actually work? Well, the lead researcher, Tong, explained three key innovations. First off, they somehow managed to pack over 2 million light-based neurons onto a chip the size of a coin. Incredible. Second, it does all its complicated thinking in something they call an optical latent space. Basically, a world of pure light where it can process ideas without ever having to convert back to slow, inefficient electricity. And third, it learns from patterns, kind of like how we do, which makes it super efficient. So you put all those innovations together, and what do you get? You get a chip that can do the entire creative process, from understanding what you want, to coming up with ideas, to creating the final product using nothing but light. And the quality? It's already right up there with top systems like Stable Diffusion. All right, let's talk numbers, because this is where things get, well, honestly, a little bit crazy. The scale of this breakthrough is just hard to wrap your head around. Compared to the best electronic chips, the top GPUs you can buy today, initial tests show LightGen is over 100 times faster and over 100 times more energy efficient. Look, this isn't just a small step up. We're talking about 2 orders of magnitude better, and that's from the very first prototype. It's just staggering. But wait, that's just the start. That's the prototype. As this technology matures, researchers project that these optical systems could become up to 10 million times faster than what we have now. And if you thought that was wild, the potential for energy savings is even more mind-blowing. We are talking about a future where AI could be 100 million times more energy efficient. In an age where Moore's law is hitting a wall and our chips can't get much better, These numbers aren't just an improvement, they're a whole paradigm shift.
Okay, so let's zoom out for a second. This is so much more than just a faster chip. This is a technology that could literally redefine the future of intelligence, and that impacts every single one of us.
So why should you care? What does this actually mean for us? For one, it means sustainable AI that isn't, boiling the planet. It means AI that's faster and cheaper for everybody to use. It means having powerful AI right on your phone, not just something stuck in the cloud. And maybe most importantly, it means speeding up discoveries in everything from medicine and new materials to art and science. Now, we have to be realistic here. This is still a research prototype. It's not going to be in your phone tomorrow. But as the lead researcher Tong says, it opens a completely new path. It's not just an improvement on the old way, it's a whole new road for how we think about building intelligent machines. And all of this leaves us with one final, massive question to think about. For the last century, we've built our intelligence out of electricity. What becomes possible for science, for our creativity, for all of humanity when we start building intelligence with the speed and the power and the efficiency of light itself?